Dear students and my dear friends, today in this session of production and industrial engineering, we are going to discuss topics from the subject of tool engineering, which is an important subject for production and industrial engineering students. So, the various topics we are going to discuss are related to the principle of locations. And I hope all of you will understand and enjoy this discussion. So, let us start with the first topic of this discussion. First of all, rationale of this subject, that is why this subject is important for production and industrial engineering students. So, diploma holders studying this course are required to supervise and work in tool room, tool design sections and production shop in the industry. They are supposed to have knowledge about cutting tools, jigs and fixtures. So, principles of locations, press tools and modules for plastic processing. This subject aims at development of skills in design and drawing of various types of jigs, fixtures and press tools, dies for plastic processing. Locating. What is locating? The question of properly locating, supporting and clamping the work is important since the overall accuracy is depend primarily on the accuracy with which the workpiece is consistently located within the jigs or fixture. There must be no movement of the work during machining. Locating refers to the establishment of a proper relationship between the workpiece and the jigs or fixture. The functions of clamping is to exert a force to press the workpiece against the locating surfaces to hold it there against the action of cutting forces. So, basic principles of locating. Locating and clamping are the critical functions of any work holders. To perform properly, work holders must accurately and consistently position the workpiece relative to the cutting tool, part after part. To accomplish this, the locators must ensure that the workpiece is properly referenced and the process is repeatable. Referencing and repeatability. The reference is a dual process of positioning the workpiece relative to the work holders and the work holder relative to the cutting tools. Referencing the work holder to the cutting tool is performed by the guiding or setting devices. With drill jigs, referencing is accomplished using drilling bushes, and with fixtures, referencing is accomplished with fixture keys, fillers gauges and or probes. Referencing the workpiece to the work holder, on the other hand, is done with locators. So, if a part is incorrectly placed in a work holder, proper location of the workpiece is not achieved and the part will be machined incorrectly. Likewise, if a cutter is improperly positioned relative to the fixture, the machine detail is also improperly located. So, in the design of a work holder, referencing of both the workpiece and the cutter must be considered and simultaneously maintained. Repeatability is the ability of the work holder to consistently produce parts within tolerance limits and is directly related to the referencing capability of the tool. The location of the workpiece relative to the tool and of the tool to the cutter must be consistent if the jig or fixture is to maintain desired repeatability. The work holder must be designed and accommodate the workpiece locating surfaces. The ideal locating point on a workpiece is a machined surface. So, machined surface permits location from a consistent reference point. Cast, forged, sheared or sawed surfaces can vary greatly from part to part and will affect the accuracy of the location. The mechanics of locating. A workpiece free in space can move in an infinite number of directions. For analysis, the motion can be broken down into 12 directional moments, or we can say 12 degree of freedoms. All 12 degree of freedom must be restricted to ensure proper referencing of a workpiece for the machining purpose. So, here in this figure 1, we can have a workpiece in space with the 12 degree of freedom. So, as shown in this figure, the 12 degree of freedom all related to the central axis of the workpiece. Notice the 6 axial degree of freedom and 6 radial degree of freedom. The axial degree of freedom permits straight line movements in both directions along the 3 principal axes shown as x, y and z. These are the 3 principal axes: x axis, y axis and z axis. In that way, the axial moment is plus x, in that way the moment is minus x. Similarly, on y axis, this way the moment is plus x and this way the moment is minus y. Similarly, on z axis, this way is the plus z and this way is the minus z. The radial degree of freedom permits rotational moments in both clockwise and counterclockwise radiation directions around the same 3 axes. So, these are the clockwise and counterclockwise direction on x axis, and this is the clockwise and counterclockwise direction on y axis, and this is the clockwise and counterclockwise direction on z axis. The devices that restrict a workpiece movement are the locators. The locators therefore must be strong enough to maintain the position of the workpiece and to restrict the cutting forces. This fact also points out a crucial element in work holder design. Locators, not clamp, must hold the workpiece against the cutting forces. Locators provide a positive stop for workpiece placed against the stop. The workpiece cannot move. Clamps, on the other hand, rely only upon friction between the clamp and the clamped surface to hold the workpiece. Sufficient force could move the workpiece. Clamps are only intended to hold the workpiece against these locators. Next is forms of location. So, there are general forms of locations. Number 1 is plane, number 2 is concentric, and number 3 is radial. Plane locators locate a workpiece from any surface. The surface may be flat, curved, or have an irregular contour. In most applications, plane locating devices locate a part by its external surfaces. For example, in figure 2a, here we can say that in figure 2a, this is arrangement of plane locator, and figure B is concentric locator. Similarly, in figure C, we can show a radial locator. So, first of all, we are going to discuss the concentric locators. So, for the most part, locate a workpiece from a central axis. Here we can see that this is a workpiece which is located from the central axis. The axis may or may not be in the center of the workpiece. The most common type of concentric location is a locating pin placed in a hole. Some workpieces, however, might have a cylindrical projection that requires a locating hole in the figure. So, as shown in figure 2b, the third type of location is radial locators. So, radial locator restrict the moment of a workpiece around a concentric locator. So, figure 2c, in many cases locating performed by combination of these three locational methods. So, locating from external surfaces, flat surfaces are common workpieces featured used for locations. So, locating from a flat surface is a form of plane location. Sports are the principal devices used for the locations. The three major forms of sports are called solid, adjustable, and equalizing sports as shown in this figure. So, figure shows that the solid sporters, adjustable sporters, and the equalizing sporters. So, first of all, solid sporters are of fixed height locators, as we can see in this figure. They precisely locate a surface in one axis. Through solid sporters may be machined directly into a tool body. A more economical method is using installed sporters such as rest buttons. Whereas in adjustable sporters, as we can see in this figure, sporters are variable height locators like solid sport. They will have also precisely locate a surface in one axis. So, these sporters are used where workpiece variation requires adjustable sports to suit different heights. So, these sporters are used mainly for cast or forged workpieces that have uneven or irregular mounting surfaces. Similarly, in this figure, we can see the equalizing sporters arrangement. So, these are the form of adjustable sport used when a compensating sport is required. Compensating sport is required from both the sides. Although these supports can be fixed in position, in most cases equalizing supports float to accommodate workpiece variations. So, as one side of the equalizing support is depressed, the other side raises the same amount to maintain part contact. In most cases, adjustable and equalizing supporters are used along with solid supporters. So, this is the arrangement of solid, adjustable and equalizing supporters to locate a workpiece from a flat surface. So, locating a workpiece from its external edge is the common or the most common locating method. The bottom or primary locating surface is positioned on three supports based on the geometry principle that 3 points are needed to fully define a plane. Two adjacent edges, usually perpendicular to each other, are then used to complete the locations. The most common way to locate a workpiece from its external profile is the 3-2-1, or we can say the 6-point locational method. With this method, 6 individual locators reference and restrict the workpiece. So, here in this figure 4, we can see the arrangement of 3 supporters on the primary locating surface restrict 5 degrees of freedoms. So, here this is the plate or the workpiece, and these 3 locators are placed inside this workpiece. So, we can say from this front view these 3 locators, and this is the side view of this arrangement, we can say that 2 locators. So, how these 3 locators restrict 5 degrees of freedom are as shown in this figure. 3 locators or supporters are placed under the workpiece. We can see in this diagram these 3 locators are placed under this workpiece. 3 locators are usually positioned on the primary locating surface. This restricts axial moment downward along minus z axis on this way. This is the minus z axis, which is the traditional 6th degree of freedom, and radially about the x and y axis, that is 7th, 8th, 9th and 10th axial moment. So, together the 3 locators restrict 5 degrees of freedom. So, here in this figure 5, we again adding an additional 2 locators on a side which restrict 8 degrees of freedom total. So, these are the 3 locators which we have already placed under this workpiece, and side by side we have placed these 2 locators on the side. So, totally 8 degrees of freedom is restrict with these 5 locators, 3 behind this plate and 2 on one side this plate. So, this is the top view of this arrangement, this is the front view of this arrangement, and this is the side view of this arrangement. So, the next two locators which are placed on a side are normally placed on the secondary locating surface as shown in this figure. So, they restrict an additional 3 degree of freedom by arresting the axial moment along the plus y axis, that is third degree of moment in traditional method, and the radial moment along the z axis, that is 11 and 12 degree of freedom. So, here in this figure we can see that this is the plus y direction and this is the clockwise and counterclockwise direction along z axis. So, additional 3 degree of freedom and a total of 8 degree of freedom is restrict with this arrangement. Similarly, in this figure, additional a final locator to another side restricts total 9 degree of freedom, which completes the 3 to 1 location arrangement. So, this is an additional locator placed on this side. These are 3 locators placed behind this plate. These are 2 locators already we have placed on one side, and again this is the 6th locator placed on the other side. So, this is the top view of this arrangement and this is the front view of this arrangement. We can see that this is the additional third locator we have now placed and this is the side view of this arrangement. So, totally with this locator we restrict this way moment and clockwise and counterclockwise moment around this way. So, the final locator as shown in this figure is positioned at the end of the part which is shown in this way, the left side of this plate. It restricts the axial moment in one direction along minus x axis. This way is along minus x axis. Together these 6 locators restrict a total of 9 degree of freedoms. So, these 6 locators 1, 2, 3, 4, 5 and 6 restricts the 9 degree of freedom. The remaining 3 degree of freedom out of 12, that is in traditional 1st, 4th and 5th, will be restricted by the clamps which we provide later to this arrangement. So, although cylindrical rest buttons are the most common way of locating a workpiece from its external profile, there are also other devices used for this purpose. So, these devices include flat-sided locators, V-locators, nest locators and adjustable locators. So, locating from internal surfaces. Locating a workpiece from an internal diameter is the most efficient form of location. The primary features used for this form of location are individual holes or hole patterns. Depending on the placement of the locators, either concentric, radial or both concentric and radial location are accomplished when locating an internal diameter. So, plan locator is also provided by the plate used to mount the locators. The two forms of locators used for internal location are locating pins and locating plugs. The only difference between these locators is either size, that is locating pins are used for smaller holes and locating plugs are used for larger holes. So here in this figure 7, the two locating pins mounted on a plate restrict 11 out of 12 degree of freedom. So here we can see that in this arrangement, this is the workpiece from front view, this is the workpiece, and this is the plane locator. This is the plane locator. This is the concentric locator, and this is the radial locator. From here in front view, you can see that radial locator and concentric locator. So as shown in this figure, the plate under the workpiece restrict 1 degree of freedom. It prevents any axial moment downward along minus z axis in this way. This plate restricts this way moment, that is minus z axis moment. The center pin acting in conjunction with the plate as the concentric locator prevents any axial or radial moments along or about the x and y axis. So together these two locators restrict 9 degree of freedom, as we can see in this arrangement. So the final locator, the pin in outer hole, is the radial locator. So this is the radial locator in outer hole, and that restricts additional 2 degree of freedom by arresting the radial moment around z axis, that is the moment 11 and 12 in traditional methods. So together the locators restrict 11 degree of freedom with this arrangement. The last degree of freedom in the plus z direction, that is the upward direction, will be restricted with the help of a clamp. So analyzing machining forces. So in this case, the cutting forces in a milling operation should be directed into a solid jaw and base of the vise. So here this is a plain milling cutter which moves in this direction, and these are the machining forces, and this is the clamping force in that way. This is the workpiece and this is the vise where this workpiece is hold. So the most important factor to consider in fixture layout are the directions of magnitude of machining forces exerted during the operation, as shown in this figure. The milling forces generated on a workpiece when properly clamped in a vise tend to push the workpiece downward and towards the jaw. This is the downward force and this is towards the jaw. The clamping action of the movable jaw holds the workpiece against the solid jaw and maintain the position of the part during the cut. So here in this figure, the primary cutting forces in a drilling operation are directed both downward and radial about the axis of the drill. So here is the workpiece. These are the various clamping forces in this fraction, and this is the machining process, and this is the radial forces, and this is the axial forces. So another example of this cutting force on a workpiece can be seen in the drilling operation as shown in this figure. The primary machining forces tend to push the workpiece down into the work holder supports. An additional machining force radially around the drill axis also force the workpiece into the locators. The clamps that hold this workpiece or intend only on hold the workpiece against the locators and to maintain its position during the machining cycles. So, the only real force exerted on the clamp occurs when the drill breaks through the opposite side of the workpiece. The clamps action of the part on the drill. The machining forces acting on a correctly designed work folder actually help hold the workpiece.